The integral says x. Our answer says theta. We've got to get everything back in terms of x. So here's the last part, which is one more layer to the difficulty of something like this. You ready? What was the original substitution that I made? The original substitution. The trig sub. That's what I did, right? Okay. I'm going to draw you a right triangle real quick. Call this angle theta. According to this equation, if I were to take this equation and divide both sides by 4, do you agree that the equation would say sine theta is x over 4? Yes. And then if I'm drawing this right triangle, if I wanted this triangle to represent that equation, I would put x here and 4 here, wouldn't I? Right. Then sine of theta would be x over 4? The reason I'm doing this is because I'm interested in knowing what cosine of theta is, right? And on this triangle, cosine of theta would be this side over this side, wouldn't it? Can you find the adjacent side of a right triangle if you have two sides? Yes. So you can solve for this side? I trust you can. A squared plus b squared is c squared. You set up the equation. You'll get this, 16 minus x squared. That's what you get right here if you solve this. Do I need to show that? Sure? Okay. So what's cosine theta? This over 4, right? Cosine theta is this over 4? So I'm going to go back in here and replace all of my cosine thetas with this over 4. So I get 1024 over 3 times, what? Root 16 minus x squared over 4 cubed plus 1024 over 5 root 16 minus x squared over 4 to the 5th power plus c. There's a little more. No, just a little bit, just a little bit. Just a little bit more, just simplification. Do you remember how we got 1024? That was 4 times 4 times 4 times 4 times 4?
64 times 16.
It was 4 cubed times 2 more 4. So it was 4 to the 5th power, isn't it? Isn't that 4 to the 5th power? Okay, so this is 4 to the 5th power. And this is 4 to the 5th power. Do you see why I'm doing that? If you cube the top and bottom here, this will be 4 cubed. 4 to the 5th over 4 cubed will cancel out some, and you'll really just be left with what? 4 squared, which is 16. So this is really negative 16 thirds square root of 16 minus x squared, that cubed. Same story here. This is 4 to the 5th, right, on the bottom? But then 4 to the 5th up here, and they cancel completely. And you're left with 1/5 square root 16 minus x squared to the 5th plus c. Now we're there. Check it. Take the derivative. I wonder if the other way, if our answers would have looked the same. We won't go back. I have enough time to do another problem, so that's what I'm going to do. Any questions? That's a lot of work, right?
Yeah.
Okay.
And that's only with
Partial credit.
A problem like that on the test, if we didn't take out like we didn't cross out the
Like this
rules
thing,
that.
I should be able to notice it, and I really, again, it will be more disappointment than it will be anything else. Yeah.
Good.
Yeah. But I mean, you should be like, you know, hard on yourself, like to go that far and then just not reduce a fraction. You know, like.
Well, you look up, it's exhausting.
Yeah, it is, I guess.
It says the 1024 is already.
Whatever.
I
Okay.
didn't think of that.
Yeah.
Now, what happens if instead of this, we have this. Are those the same?
No.
They're not, right? Now you might say to yourself, well, I can just factor out a negative from here, right? If you factor out a negative, then it makes this negative and that positive, right? So it would be like, do you agree? Like pass that back through, you get this? So you may say, okay, well, if I ever see this, which is that one reversed, then I'll just pull a negative out and then do the same thing. Here's the problem. You can't pull a negative out of a root, right? This is like square root of -1, which is an imaginary number. So these are not the same, just a negative pulled out. So what happens when we have that versus this? And it turns out we're going to do just a different trig substitution. Instead of doing a sine theta, we are going to do what? It's on the bottom here. Do y'all see this table now? Look at the table on the bottom. Do you see where it says the expression on the left side? And you see where it says the substitution in the middle? And the identity that you're going to use? That's what that table means now. Does it make sense? Okay, so for this we will use a secant theta. And if there's a plus between them, this one, it could be reversed, right? These are the same thing? In that case, we'll use a tangent theta. So we have 3 different trigonometric substitutions that we use. So let's try and do one last example, which will be A. So I don't know if you remember me saying this, but I do this first exam a little early in the semester compared to other Cal 2 classes. A lot of other Cal 2 classes, they do all the techniques of integration first, which means we're in 6.2, you need 6.3, I believe just 6.3. And 6.4, 6.4 is different. That's tables, using tables in the back. So basically, there's 2 more sections, this one and one more, and that's pretty much all the techniques together, and that's where they usually have the first test. I do my first test right after integration by parts. It's 15% because if you struggle with that exam, okay, if that exam is going to be hard, then everything that we continue to do is going to be this much harder. I mean, look, this problem is requiring a lot, right? I mean, so that's why that first exam is an indicator. If you're in like the 40s on that, all the integration is what you missed, that's room for concern. All right, now I'm not saying drop the class. I think anyone, even if you wound up not passing this class, should stay to the end, no matter what. But you should not be afraid of, I might have to retake this class. Because there's no shame in retaking Cal 2. A lot of times students have to see it twice, because the first time you see it, it's like, holy shit, you're not ready for it. Okay? So, all right, here we go. So we look at it, we try some other method, we're like, oh wait, square root this thing. I know that I can do trig subs when I see that, right? So what's the trig sub I'm going to use? So I'm going to do the x is going to be replaced with a tangent theta, according to what it says there. So x will be, for us, what's a? 3, so 3 tan theta. Anybody have a question on why I chose that? Or okay, so now I do my derivative both sides. What's dx? Well, you need to know what the derivative of tangent is. Secant squared theta d theta, right? Yeah? And now for this one, I think I'm going to do my work on the side, because I think I'd confuse too much when I try to do it all in the integral. Let's just figure out right now, what's the x squared plus 9 going to turn into? So go in here and replace your x with with 3 tan theta. So it's going to become square root, what's 3 tan theta squared?
6 or 9.
9 tangent squared theta plus 9. And then what do they both have in common? A 9. So you can factor out a 9. Let me go ahead and do that right here. When I factor out the 9, what am I left with in parentheses?
3.
Tangent squared theta plus 1. The 9 can come out as a 3. And what can I replace tangent squared theta plus 1 with? Secant squared theta. See, that's why we use this particular trig substitution, because this thing right here is going to turn into something nice. This right here is secant squared theta, and that's just 3 secant theta. Any questions on how that works? Identify the radical, the form. Use the table to figure out the trig sub, take the derivative, simplify the radical, and then go back to this and replace everything. Do it that way? That sound good? Okay. So now this integral is going to become integral 1 over, all right, let's not forget any pieces here. We have x squared down here, bottom corner. X squared, here's x, right? Square that. 9 tan squared theta, okay. The square root of x squared plus 9. 3 secant theta. Am I done? What else? Dx, right? Replace dx with 3 secant squared theta d theta. You all see my replacements? Okay. Now I do get some things to cancel here, don't I? Those 3's are gone, aren't they? 3 on top and 3 on bottom. One of the secants cancels, and a 9 on the bottom can come out as a 1/9 on the outside. Not square rooting it. Oh, sorry, I did these 3's.
Okay.
Yeah. Then I'll still have, so we're all going to get 1/9? Yes?
Yeah.
You could pull out 3/27, but that's 1/9. So 1/9 here. Integral secant on top, right? Secant theta on top. Bottom, tangent squared theta, d theta.
You said one of the secants canceled.
Yes, one of those secants cancels. So I had a squared here, and then it cancels that one. And we all at the same place? Any questions? All right, now at this point, you might be thinking, okay, I'm going to go to my sheet because I know how to deal with secants and tangents, right? But I told you this is a strategy. It doesn't always work. The problem we have is that this is a fraction. And so this method was really good when we had tangent and secant together, next to each other. Not so good with something like this where they're separated in a rational expression. So what did I say we can do, or you might want to try, if you ever kind of hung up on an integral that has trig, turn it into sine and cosine, right? Turn this into sine and cosine. So let's see. What is the definition of secant? 1 over cosine. And what is the definition of tangent squared? Sine squared theta over cosine squared theta, right? That's what that would be. Just me rewriting the entire integral in terms of sine and cosine. Secant theta, tangent squared theta. Flip, right? Flip. When I flip that up, what is it? One of the cosines cancels. So I have what then? You tell me. Cosine theta. Go ahead. What?
Cosine over sine squared.
Cosine over sine squared. Cosine theta over sine squared theta, d theta. So just flip it, right? One of the cosines cancels. So you have a cosine over sine squared. All right, U substitution. Basic U, good old U substitution. What's the U sub I'm going to use here? U is sine theta, because its derivative is where? On top, right? So that integral is really nice, turns into what? 1/9 integral 1 over u squared du, which is negative 1/9 u to the negative 1 plus c. So I'm doing that antiderivative kind of mentally. Do y'all agree that's the antiderivative? And take the derivative, you'll get that, right?
Yes.
Okay. And maybe we like it written like this instead. Negative 1 over 9u plus c. I don't know. Maybe not. I don't know. Do you like that? Not really? Okay. What's u?
Sine theta.
Sine theta. So negative 1 over 9 sine theta plus c. But I need it in terms of x. So you need to know what sine theta is. Where did I pick up that in the last problem? Where did I figure out that cosine theta from? From a triangle, right? Where did that triangle come from? What information did I use to draw that triangle?
What you used at the very beginning?
The substitution that I used to start the problem. So what substitution did we use for the trig? What was 3 tangent theta? X was 3 tangent. So I'm going to write that down again. X was 3 tangent theta, right? X was 3 tangent theta? Okay, so let's get tangent theta by itself. So x over 3 is tangent theta. We call this a reference triangle. Back in pre-cal, we call these reference triangles. We're just using them as a reference to help us. So right triangle, theta. Tangent, by definition, is opposite over adjacent. So x is this side.
A is the bottom.
A is 3. And so a squared plus b squared equals c squared. When you do the math, you can get this. It's 9 plus x squared. Does that look familiar, though? 9 plus x squared. That was that radical that was in the problem, wasn't it? It happened last time, yes. Yeah, on your right triangle, one of the sides has to be what the original square root thing was. Yeah. Because everything was based off of that, right? The whole picture was based, or the whole substitution was based off of that idea. Okay, so can you tell me what sine theta is? Sine is this over this. So you could write down here x over that other one. Or, how about this? Isn't this the same as negative 1/9, what, cosecant theta plus c? Isn't 1 over sine cosecant? And then cosecant is the reciprocal of sine, so instead of this over this, we just do this over this, which is the same as putting it down here and flipping it back up. It doesn't matter, it's all the same. You're going to get the same result, yeah. So we have negative 1/9. And then finally, root 9 plus x squared over x plus c. There it is. And to check it, we would do a quotient rule, right? That's what that would require, quotient rule. And if we did it, we should get back the original integrand. Boy, that didn't take me as long as I thought it would. Let's see if I can get through one more, okay? One more? Y'all doing all right? We have 20 more minutes. Y'all doing all right? Breath. What? I've got a new one. Yeah, thank you for noticing.
Oh, yeah.
Yeah, that would suck. That's why I've been looking at the camera the whole time. Looks like I'm looking at you. I'm looking at the camera to make sure the bar is moving when I'm talking. Hello, hello.
You plug in your receiver right there?
My receiver's right below the camera. Yep. That's an expensive,
Yeah.
this is an expensive microphone set. Yeah. Greater than 0, less than infinity. But just in case my wife watches this video at some point in time, I won't mention how much it was. She doesn't watch them, but she'll watch just this one, and she'll know how much I paid for it. Okay, let's get on to man, I don't know if I like the way this one's going to work out. This has the same trig sub in it, though. All right, we'll do it. Okay, you ready? This one is not maybe as obvious that this is going to be a trig substitution. But that 3/2 power means the square root of something cubed, doesn't it? And I want you all to keep this in mind because this might come into play at another point in time also in a different problem when you're doing your homework. If I have something like this squared, that doesn't seem like it falls into this category, does it? But you could rewrite that like this to the 4th power. And remember, this is just going to turn into some like, cosine theta or something like that, right? To the 4th power, we can deal with that. So just be aware of kind of hidden square roots. They're going to sometimes be there, all right? All right, so we okay? Yes? All right, so let me rewrite that just so it glares at you a little more. Okay, we good with that? That's what that means. Raised to the 3/2 means square root cubed, doesn't it? Square root cubed. Now, does that look like one of the forms on your sheet?
Yeah.
Kind of, right? Looks like the the x squared plus a squared. But the 4 can't be here if we're going to do this. So you had the question, can you pull out, or can you take out the 4? Yes, you can. Let me watch how I'm going to do this. Do you agree that 4x squared plus 9 is the same as 4 times x squared plus 9/4? Yes? So I can pass that back through, I get this, right? So I'm going to pull a 4 out of this, and then it's going to pop out of the root and become a 2. And then it's going to get cubed and become an 8 and go all the way out of the integrals of 1/8. Should I do that again? No? 4 comes out. 4 is out here. Parentheses are there. Square root of 4, 2, cube, 8, 1/8 on the outside. Okay. Now you can take it a little slower if you want, but that's what I'm about to do on the next line because of time. Yeah, once you see it the first time, then you know kind of what I'm doing. This is now going to be square root what cubed? X squared plus 9/4, right? Now that looks like x squared plus a squared. All right, what's my trig substitution going to be? X is a tan theta, right? That's the one I'm going to use. X is a tan theta. What's a for me here? I should write down what a is. 3/2, right? It's the square root of this number. So square root of 9 is 3, square root of 4 is 2. So 3/2. So my trig sub is going to be, x is going to be a tan theta again, right? Okay. You can go through all the work, take the derivative over here. Derivative of x is 3/2 secant squared theta d theta. what should I do next? You want me to do the x squared plus 9/4 under the root, simplify all that? Okay, so let's do that right here. What is this piece right here going to be? It's going to be square root of x squared plus 9/4. That should be equal to square root. X squared is this squared. Hey, that's 9/4. Good, I'm glad to see you. Tan squared theta plus 9/4, right? So squaring x, what do they both have in common? 9/4, pull that out. Pull out of the root as 3/2. Root tan squared theta plus 1. Tan squared theta plus 1 is really secant squared. Pull out, or take the square root of secant squared. So 3/2 secant theta. Now some formula sheets, have y'all noticed that the same thing keeps on popping out every time that we do this? Some formula sheets will actually tell you what the square root of all that junk is going to turn out to be also. I just think it's more constructive for you to do this because you can just get better and just get your algebras just solidified a little more this way. All right, I'm ready to rewrite this thing. I'm excited about it. All right, I'm kidding. All right, so 1/8, right? Integral x cubed on top. Well, you get to cube this, right? What's 3 cubed? 27. 2 cubed. 8. Tan cubed. Well, tan cubed, right? Over. Okay, this square root thing turned into 3/2 secant theta, didn't it? That's what the root was. But then what? Cubed. And then don't forget dx is what? 3/2. Dx is 3/2 secant squared theta d theta. A lot of that stuff are just numbers that we can get out of there. What is 3/2 cubed? 27/8, right? So that and that are going to be gone, right? And that's going to be cubed here. So we just have a 3/2. This 3/2 didn't get touched, did it? So take that out. Becomes what? 3/16. Integral. All right, what have I got on top? Tan cubed secant squared, but on the bottom secant cubed. So the secant squared cancels, and I'm left with 1 secant on the bottom. Tan cubed theta over secant theta d theta. We have 10 minutes. So tear out a sheet of paper. Let's do just a group quiz. Finish this right here. All right? No, you each have your own paper. I want to see if you can take that the rest of the way. You have 10 minutes, though, 11 minutes. If you're able to take this all the way, try and get everything back in terms of x and get a final answer for this problem. Okay? Question? No, not everything. Just start by writing this right here. 3/16, this integral, and then work it from there. You have a question?
I did, but just because I can do something.
You got it? So we're good with you watching a video, I guess, huh? Check your email for Thursday. Thursday's class. If you came in late, Thursday we're not going to have class. I have an appointment I can't get out of. So I'm going to send a link with an email link to a video to watch. That's what everyone agreed on. Almost everyone agreed on.